Good morning. Right, people, today we're supposed to start the integration part. Right, we tried the heading as integration. Right, the heading as integration. Okay, we know, people, integration is the opposite process of the differentiation. You know, when we differentiate, for example, sin x function with respect to x, the answer is cos x. Answer is cos x. Then starting from this derivative cos x, obtaining this original function sin x is called as the integration. So then we write, starting from this, obtaining this function is written as integration of cos x with respect to x. This is how we write that. Integration of cos x with respect to x is this sin x. This is how we write. And the other thing is, people, now when we consider this function sin x plus c, this c is any constant. C is any constant. Okay. When you differentiate this sin x plus c function with respect to x, here we get cos x and plus derivative of c is 0. Then still we have cos x here. Then the integral of this or integration of this cos x, again we can write integration of cos x is now, people, this sin x plus c. What is c? This c is any constant. Any constant is called as the arbitrary constant. Arbitrary constant. Then this is that arbitrary constant. Any constant. Right. Then you can very clearly see here, in this result, the cos x function we have integrated. Here also, same cos x function we have integrated. Then here the answer only sin x. Here the answer is sin x plus c. C is any constant. Then you can see by this result, since c is any constant, put in for this c 0. Once you put for this c 0, what we get is sin x. This answer coming. Therefore, since this answer also available in this answer when c equals 0, here you can see this is coming. So therefore, we accept this as the most general answer of this. Understand? So thereby you have to get another idea that after integrating any function to the answer, we have to add this c, any constant. Any constant means, people, arbitrary constant. Okay, so therefore, after integrating any function, remember to add the constant. That constant is, people, arbitrary constant. Right, now the answer we get this way is called as the integral, and the function we integrate is called as integrand. Integrand. Answer is called as the integral. The function we integrate is called as the integrand. Integrand. Okay. Right. So this only first we have to understand. And people, we have some results. I'll give you that results. Nearly 27 results we have. After 29 results we have. Those results, people, very important throughout this lesson. Remember those results. Thereafter, today I supposed to do all the theories by doing 2-3 questions from each kind. I thought of doing this lesson without discussing the theories and straight away working out questions. But finally, some requests were there. So we haven't done that integration so far in our theory classes also. Then please start from the beginning. Some other students from other classes, they are coming to our class, requested like that. So therefore, I thought of doing the lesson again from the beginning so that they will get particular advantage by doing so. So therefore, today I supposed to discuss the basic theories. I supposed to finish them all today, and I have given you one tutorial I have put that to the group, and people another tutorial available there. It contains nearly 16 questions. That tutorial you will get tomorrow evening. So then once we do questions in both tutorials, people, I think we can completely finish this integration so that the question at the paper you can work out. So therefore, the theory students sometimes today they might feel the basic part is really doing. Yeah, people, today I supposed to do like that because of the request of the other students, right? And even though you have done this one, people, it's a good thing to remind that again. Then you can, of course, very easily remind everything from the beginning in the lesson you learned in theory class. Okay, right? I think that if I don't do this theory parts from the very beginning, some of the students will find inconvenience. Then, of course, that is not good. Will do from the beginning. I am going to give you some important results after this. Thereafter, we come to one by one the theories, and thereafter, today I supposed to finish, but most important theories only I supposed to discuss here. That in the sense by observing the past paper sums. According to the past paper sums, of course, even though in the theory classes I have done lots of theories, people, some of them, of course, very important in your future studies. But when we consider at a glance in the past papers, people, some theories only in the past papers they have used so far in giving the questions when you go to the combined math history. So then I am going to focus only those situations, those theories, and then I try to finish this lesson so that you can very easily work out the question at the examination. Okay, right. So then people will write the integration heading. Then we can take this one's example, right? Write down, people, first one like this. This one, and write down this. Secondly, come to this. And then we'll write, this is arbitrary constant, right? This C. Right. I will write one sentence, people, in this. Okay, first write down this. Write down using the derivative, the process of finding, using the derivative, the process of finding original function is called as the integration. Is called as the integration. write down after every integration, an arbitrary constant is added to the final answer. Right. Right. People, now in this case, after integrating this cos x function, this is the general answer, the common answer, general answer, or the fair answer. In this C is, people, arbitrary constant. Arbitrary means any constant we like. We can put people any real number for the place of C. Due to this, people, this right hand side is not having a definite value. The right hand side can take any value, because the first reason is this C can be any real number. Once this C can take any real number, people, the right hand side can take different answers. So therefore, this has no definite value to the right hand side. To the right hand side, it has no definite value. Therefore, this integration is called as indefinite integration. Indefinite integration, right? Indefinite integration. Indefinite integration. Okay. Now we secondly learn definite integration. Definite integration. In that definite integration, people, to the right hand side, we get a definite constant value. Definite constant value. Okay. Right. Write down this way also. Write down, since the final answer after integrating we get is not a definite value, this integration is known as indefinite integration. Indefinite integration. Write down, and the function we integrate is known as the integrand. This integrand. And the answer after integrating we get is called as, and the answer after integrating we get is called as integral. This integral. Right. Even now I am going to give you some important results that you have to put in your notebook itself, right? And after getting this, you have to take that to another separate piece of paper. That will be very helpful. I think as long as you can remember these results, you can work out the integration lesson. This is, people, another easy lesson. Another easy lesson. But this 29 results we have, you have to remember them. then a smooth flow available in this lesson too, right? Little bit more theory is available, but I am going to focus in this case, in this revision lesson in integration, only the most important theories that we use to work out the questions in the paper, right? Yeah. Write down subheading as important results in integration or fundamental results in integration. Fundamental results in integration. Right, people, these results we have to understand. When we integrate x to the power n, this n is not equal to minus 1. Its answer is x to the power n plus 1 divided by n plus 1, n not equal to minus 1. Right? For example, if I consider x to the power 5 dx, then add 1 to this power n by the new power divide. X to the power 5 divide 5 plus 1 now, divide by 5 plus 1 plus c, and then we get x to the power 6 divided by 6 plus c. C is an arbitrary constant that I write as c is any constant. C is any constant. That way, this result is important. N is not equal to minus 1. When n equals minus 1, people, minus 1 plus 1, this is 0. Then the denominator 0 means that answer is infinity, has no meaning. That is why we write there n not equal to minus 1. Right. When n equals minus 1 case, people, when n equals minus 1 means x to the power minus 1, no, that is 1 upon x. In that case, the result is the second one. Once we integrate 1 upon x function with respect to x, its integral is, people, ln x. Ln x. Ln modulus of x we have put here. Because you know ln means logarithm to the base e. Logarithms cannot be found for negative values. Ln mod x usually we write. Modulus we have to put here. Though you put modulus x here, that's actually we have to put the modulus x here, right? Ln x. Here, people, I must add a constant, but since this is a result, we'll keep without adding a constant. But when we answer a question, people, finally we'll write a constant here. Right. 1 upon x, when we integrate, we get ln x. Like this, people, there are nearly 29 results. We have to remember those results. If you can remember them, people, you can work out all integration questions, right? Number 3, third one is this. Integration of ax plus b to the power n with respect to x, right? Here also this n not equal to minus 1. Within bracket, what you have is a linear function in x. A linear function in x. Linear function means first degree polynomial in x. Then in this case, the integral is, people, add 1 to this power, divide by the new power, and divide by the x coefficient, like this. X coefficient. Then here n should not be equal to minus 1. N not equal to minus 1, because when n equals minus 1, this denominator is 0, then this has no meaning, right? For example, here when I take 2x minus 1 to the power 4, if we need to integrate, people, you have to add 1 here and divide by the new power multiplied by the x coefficient plus c. C is any constant. is any constant. These things really we did in theory classes also, but due to the request of the students only, I supposed to do this again. Otherwise, of course, I have decided without doing these things to do the question straight away, right? But people, it takes nearly 1 hour. Actually, though we sacrifice 1 hour for this, that will be given a huge advantage when you proceed the lesson in the future, right? People, next one is when n equals 1 minus 1. This will be 1 upon ax plus b, no? Then when n equals minus 1, the result is this. 1 upon ax plus b dx. This one, people, 1 upon ax plus b. The denominator we have, people, linear function in x, first degree polynomial in x. People, in this case, the answer ln modulus ax plus b, and divide this by, people, x coefficient. ln mod ax plus b divided by x coefficient. Number 4. Number 5. When you integrate 1 with respect to x, it is x. Now, people, for this one, when you take an example, right, this one, if I take 1 upon 3x minus 1 dx, what is the answer? The same thing we have tried in modulus after writing ln. ln means log to the base e, and divide by the x coefficient, it is 3 plus c. C is any constant. C is any constant. Like that. Number 6. Integration of a dx. It is ax. What is this, people? A is a constant. A is a constant. A is a constant. That means if we have 2 dx, what is the answer? 2x plus c. C is any constant. People, after getting this way, the answer, writing here c, and you must write that c is any constant. For that, you get 5 marks. Okay. And remember, the same thing you can think like this, 2 people. Integration of 2 dx, no. Here, since this 2 is a constant, you can take this 2 out. Then here we have now 1 dx. But integral of 1 going to be, people, here x, no. Then for this I can put x. That way also you can think. That also you can think. Right. Number 7. Number 7. Suppose we have something like this. F dash x divided by fx dx. Right. What is this form? The denominator, we have a function fx. F dash x means, people, the derivative of this fx. The numerator we have the derivative of the denominator. When you differentiate this denominator fx function, what is the answer we get? It is at the numerator. If we have this kind of integrand, a function to integrate. People, the answer, remember, answer is L in modulus this denominator. This way, right? Number 7 is that. Now, for example, here look at this. We have sin x as our fx function. But you know, the root of sin x is cos x, no? See here, we have. Now, this sin x is your fx. When you differentiate sin x, what is the derivative? Cos x, f dash x. Then this theory gives us the answer of this is L in modulus this denominator. That means, people, when you differentiate this, the derivative comes like this. Understand? People, always we integrate a derivative. Always we integrate a derivative with the intention to find original function. So then this is the original function. Once we differentiate as its derivative, this comes, right? So then let's see. C is any constant, right? And another one example, people, if I consider like this, 1 upon 1 plus x squared tan inverse x dx. When you integrate this also, people, we can prepare like this. How? This 1 upon 1 plus x squared we can write like this. 1 upon 1 plus x squared we can write like this. And this tan inverse x I can write like this. Dx. Then you can very clearly understand the derivative of tan inverse x. Derivative of tan inverse x equal 1 over 1 plus x squared available at the numerator. Here the function, derivative at the numerator. Function at the denominator, its derivative at the numerator. This form. Then the answer is what? L in what? Denominator. Right? L in denominator. L in modulus tan inverse x plus c. C is any constant. Like that. Number 8 next. Number 8 is when you integrate sin x. People, integral of sin x is minus cos x. Minus cos x. You can see after a result for integration of a function, when you differentiate this, we get this sin x. Understand? This is the original function that should be differentiated to get this sin x as its derivative. Correct? No? Minus cos x, when you differentiate, we get the derivative as plus sin x. Then the integral of sin x is going to be minus cos x. Right? Okay. Number 9. Integral of cos x. When you integrate cos x, people, we get sin x. Correct? No? The sin x, when you differentiate, we get cos x. Right? Number 10. Integration of sec squared x with respect to x, tan x. Number 11. Integration of cosec squared x with respect to x minus cot x. Number 12. Integration of sec x tan x with respect to x. This is sec x. Number 13. Integration of cosec x times cot x with respect to x minus cosec x. Right. Integration of tan x with respect to x, people. Remember, tan x, it is ln modulus sec x. Integration of tan x ln modulus sec x. Number 15, integration of cot x with respect to x. It is ln modulus sin x. Number 16, integration of cosec x. Remember this result. Integration of cosec x is ln modulus cosec x minus cot x. Number 17, integration of sec x. Integration of sec x. This is, people, ln modulus sec x plus tan x. Number 18, integration of ex. Integration of ex. Integration of ex is, people, the same ex. When you integrate and differentiate the function ex, the answer is same ex. 19. Integration of eax, where a is a constant. Integration of eax. A is a constant. Then the answer is eax divided by a. A is a constant. A is a constant. Number 20. People, this one, a to the power x dx. This integral is a to the power x ln a divided by ln a. Here a is a constant. A is a constant. That means when you this way differentiate, people, 3 to the power x dx. 3 to the power x ln 3 divided by ln 3 plus c. C is any constant. Right. Because this proof of this we should know. We'll discuss that through a question, right? Number 21, people, next. Integration of 1 upon 1 plus x squared. Integration of 1 upon 1 plus x squared. This is really tan inverse x. Tan inverse x, number 21. Number 22. 1 upon a squared plus x squared dx. A is a constant. This answer people here, the answer is 1 upon A tan inverse x upon A is the answer, right? Then for example, if I consider there 1 upon 9 plus x squared dx. You can try this 9 as 1 upon 3 squared dx. Then we get 1 upon 3 tan inverse x upon 3 plus c. C is any constant. Number 23 next, people. Number 23. Number 23. Number 23 result is this. 1 upon ax plus b perfect squared plus c squared. Here, people, you can see we have linear function in x, first degree polynomial in x, ax plus b. Here, a, b, c are three constants. Then a linear function within bracket we have its perfect squared plus c squared. In this case, if we have this type of integrand, its answer, people, we can write like this. 1 upon here, this and this we multiply without taking the square here. 1 upon a and c. 1 upon ac. And tan inverse this ax plus b without the square, ax plus b should be divided by this c without the square, right? Ax plus b divided by c. This is the answer, right? See the way of remembering this. Linear function in x, perfect squared plus constant perfect squared. Then it's integral. The answer after integrating this, what we get is, people, 1 upon ac. A means the x coefficient and c the constant here. Tan inverse ax plus b divided by this divided by c. Right? And 24th result. 24th result. It is, people, this 1 upon square root of 1 minus x squared dx. This is sin inverse x. Sin inverse x. 25th one. Integral 1 upon square root of a squared minus x squared dx. People, this answer is sin inverse x upon a. Sin inverse x upon a. For this, when we consider an example, is 1 upon 25 minus x squared dx. This you can write 1 upon 5 squared minus x squared dx. This is sin inverse x upon 5 plus c is any constant. Your number 26, the result. E to the power fx into f dash x, like this, dx. See the integrand here. E to the power fx of this power derivative available here as a product. Then in this case, the answer is going to be e to the power fx. Now, for example, suppose here e to the power sine x here we have. For the place of fx, we have sine x. Here we must have the derivative of this, no? This is multiplied by cos x dx. E to the power sine x, its derivative is here. Then what's the integral? The answer is the same thing, this here. E to the power fx only the answer, like that. Fx, f dash x, sine x, the derivative of sine x is cos x. Then of this whole thing, the integral is e to the power sine x. Plus c is any constant. Right? Like that. Number 27, people, next one. Number 27, the next. Number 27 is this, a to the power fx. Here a, right? And fx derivative is f dash x. Multiplied by f dash x dx. You will now hear this a is a constant real number. People, here you know this e. What is this e? When you define the exponential function, ex function, when you define ex function, that e only here we have. Okay, right. Now here this a is any real number, right? That should be a positive real number. Then here the answer going to be, people, a to the power fx divided by ln a. E to the power fx, the same thing, divided by ln a. People, now when this a becomes e, still by using this you can take this. Suppose for the place of a we put e to the power fx into f dash x dx. Then here we get e, no? Because a now e, no? ln e means 1, people. Then we get e to the power fx, this result. Okay. Then by this result you can obtain this also. ln e means, people, ln means log to the base e, no? Log e to the base e equals 1. Okay, right. So therefore, by this we can take this. Right. Next one, people. Now I'll take one example for this. 2 to the power, I'll take here tan inverse x multiplied by tan inverse x derivative is what, people? 1 upon 1 plus x squared. No? Suppose something like this we had. See here. This a is 2. Fx function is tan inverse x. Of the fx function, derivative should be here. When you differentiate tan inverse x, derivative is 1 upon 1 plus x squared. Then, what do you get? We can apply this result there. What is the result, people? The same thing this coming. 2 to the power tan inverse x. Here, a to the power fx. This one, same way you have to get here. 2 to the power tan inverse x. Divided by, people, ln a. Ln a means this, no? Here 2, ln 2. And 2 plus c. C is any constant. C is any constant. Right. The next one, people, 28. 28 result is this. We have fx to the power n. All right. Within bracket, we have fx, its power n. This whole thing is multiplied by the derivative of the function within the bracket, f dash x dx. See here the integrand. Its form is, within bracket we have a function fx, its nth power we have, and it is multiplied by the derivative of the function within bracket f dash x. Then the integral going to be, people, add 1 to this power, all right, with fx. Fx to the power n plus 1 divided by n plus 1. Here n not equal to minus 1. N not equal to minus 1. Right? People, for this we can take one example. Shall we take this one? Tan squared x, here sec squared x, integral dx. We can take the integral of this, answer of this, by matching this with this. How, people? I can write it like this here. Sec squared x I can write. Here this tan squared x I can write as tan x to the power 2 like this dx. Correct, no? Tan x to the power 2 is tan squared x. Now consider your fx function as tan x. Then fx function derivative should be before this. When you differentiate tan x, no, people, tan x derivative is sec squared x. Then now this integrand is very similar to this. Then the answer can be written like this. What is the answer then, people? Adding 1 to this power and dividing by the new power. Here the power is 2. Add 1 and divide by the new power. 2 plus 1 is 3, no? Yeah, then what's the answer there? Tan x to the power 3 means tan cube x divided by 3 plus c. C is any constant. Like that, we get 28 form result, right? Okay, now right, the last one, people, we can take the last one. The last result is this. Number 29. Number 29, people, this. Now suppose we have a function fx. When you integrate that, suppose we get its answer capital Fx like this. Now in the function simple f, this x we replaced by a linear function. Instead of x, I write another function as ax plus b. Then it is this. Now we need to integrate this with respect to x. Then this result says us the integral of this can easily be obtained replacing the right hand side x by the same ax plus b with the function capital F. And that should be divided by the coefficient of x, a. This is what it says. Now, for example, we can write, people, this one example will take like this. We know this 1 upon square root of 1 minus x squared. When you integrate, the answer is sin inverse x, no? Okay. Now, suppose people, this x, the place of x we replace by a linear function like 3x minus 2 perfect squared like this. Dx. Here we have 1. What has happened here? For x, that x has been replaced by linear function 3x minus 2. Then according to this result, this one, we can write what? Yeah. Then here, when you integrate fx function, we get capital Fx. Like that, when you integrate this, we get sin inverse x. Now, if we replace this x by ax plus b, then the right hand side simple x also we have replaced by ax plus b, mean time divided by a. And then people, once I apply this comparison to this one, this x now we have replaced by 3x minus 2. Sin inverse 3x minus 2. Okay, this part we obtain. Divide by a. A means this x coefficient. What is x coefficient? 3. Divide by 3. This is what this result says us. Plus c. C is any constant. C is any constant. Right? Right. Now, next one. Just see people we can take. Sine 4x plus 3dx. Right. What is the answer of this, people? Right. Now, suppose here we have sine x. Here we have for whole thing sine x. People, what is the integral of sine x? Minus cos x. Minus cos. If we have only x here, integral of sine x is minus cos x. But here we have linear function for x. Then what's the answer? The same thing you must write. And that should be divided by x coefficient 4 according to this result. Okay? Plus c is any constant. Right. If I take another one more, people suppose integral of sec 6x minus 1 dx. People, if we have here without this 6x minus 1 sec x only, instead of this 6x minus 1, suppose we have x, then we have integral sec x, no? What is the integral of sec x? ln modulus sec x plus tan x, no? That we learned under number 17. Then, if we have only x here, ln modulus sec x plus tan x. Here and here we have x and x. But here we have 6x minus 1. No? So then, here we have tried 6x minus 1. And not only that, people, this whole thing should be divided by x coefficient 6 according to this result. Right? That's what this result says us. Take down these examples. Then this way, when you have sine 2x, people, then dx. What is the integral of sine 2x? Minus cos 2x by 2. Plus c. C is any constant. Cos 3x dx. What is this, people? Sine 3x by 3 plus c. C is any constant. Like that, you can take the integrals by using this result. Okay. Right, now we'll come to, people, very fundamental questions. By doing some fundamental questions, we'll see how to apply these results, and thereafter we can go for some different methods, and like that we'll try to do this lesson. That is, of course, much convenient and easy to remember the results also, right? This lesson, remember, people, very easy lesson, but these things you have to remember definitely. If you can remember this thing, I think you can work out the whole question at the paper without any trouble. Okay, right? This is another important question because 150 marks come in by this. At the most 3 parts, and 1 application might be in the paper. Application of integration, right? Then we can come to few questions, people, like this. Right, we'll do some questions and come to the other series, right? As a first question today, I take this one. Right, it is this 2x minus 3 to the power 3 divided by x cube dx as a first example. X squared, people take, not x cube also. Okay, right. How to take this answer? How to take this? Among that 29 forms, people, straight away you can't find out a result for this. Yeah, so then we can take it like this. First we expand this power 3 and divide. There will be 4 terms now. Divide every term by x squared and take individually 4 terms. Now each term we integrate separately. Yeah, when we expand this, we can expand this, taking this as a minus b to the power 3. What do you get there, people? A cube, this to the power 3, then we get 8x cube, and then minus 3 times square of this into this. No, square of this means 4x squared into 3. 4x squared into 3, then 12x squared. 12x squared and this 3, 36x squared. Right, now what is next, people? Again 3 plus sign 3 times this into 3 squared, 9 and 2x is 18x, and this 3, 54x, and 27. 3 to the power 3, no? Right? There I used the expansion of this a minus b cube, a cube minus 3a squared b plus 3a b squared people minus b cube. Then here not plus 27, minus 27, right? 3 to the power 3. Okay, no? Right. That one I used. Now divide this by this, this by this, this by this, this by this. So what do you get? 8x minus 36. This one 54 by x. This is 27 by x squared. Now each term you have to integrate, people. Here 8x, when you integrate, keep 8 out because 8 is a constant. X to the power 1, x squared by 2, no? 36x. Here 36 is a constant, no? Using the we learn now people for this one. X to the power n integral we know. X to the power n plus 1 divided by n plus 1. Then applying that, you can write here x to the power 1, no? 1 plus 1, 2. X squared by 2. Right? 36. You can remember, today we learned a dx. What is the answer? Ax. Ax. Then here we get minus 36x. 54 by x, people. 54 by x we can write like this, no? 54 into 1 upon x. Then when you differentiate, integrate this, take this 54, we integrate like this to the right hand side. You notice this 1 upon x integral is ln x. So therefore this is 54 times ln x. And this 27 we can keep like this. It's a constant, no? Take this x squared to numerator, that is x to the power minus 2. When you integrate x to the power minus 2, again that can be integrated by using this result. Adding to the power 1 and dividing by the new power. Once you add 1 here, minus 2 plus 1 is minus 1 divided by minus 1. Then what do you get? X power minus 1 divided by minus 1. This is nothing but minus 1 over x. For this one, when you integrate, we get minus 1 over x. Then with this one, we get plus. And people write c is any constant. C is any constant. Like that, you can take this answer. Right. Right, people, now. Okay, now suppose this one next. X cubed divided by x squared plus 1 dx. Suppose we need to integrate this. People try this question. Yeah, people, at once you can't see to take the answer of this directly among that 29 results. People, this only the thing you must be able to do in getting the answer. So this process, this portion, for this one straight away, you can't see an answer among that 29 results. Now, by applying some different mathematical operations, this should be converted to a form which is available among that 29 forms to integrate. That part only you must do. So then to do this one, people, you can very clearly see this one I can write in this manner. I take this x cube upon x squared plus 1 like this. This is very simple algebra. Right, people, now I write here x squared plus 1, the same denominator, right? Then I am going to write this x cube involved in this denominator x squared plus 1 like this. See here. I must have x cube only, but at the moment, numerator we have x squared. X cube we should have. Then I write x cube. Then once I multiply by this x, we get x and x squared, this x cube come in. Now the x also come in here. When you multiply this x and 1, that x should not be at the numerator. Therefore, we have to subtract that. Then once you simplify the right hand side, people, what you get is this. Then what we do is we divide this by this and this by this. Then what do you get? This and this we can cancel down. We get only x minus x upon x squared plus 1. This way we have. Then for this one, I can write this. Right. Then I can write it like this too. Integration of x cube upon x squared plus 1. People, now writing this one in this way, people, don't think this is there is more work in it. How can we get this idea whenever we start a question? People don't think like that. Remember, when you get this kind of integrand, we just try this way. Think like that and study at once, right? Don't take that is a great work and much work and how can we think like this, and don't put unnecessary feelings to your mind. If you find something like this way we can take, that's all, a simple thing. If we take this as a right, so don't expand that what situation here. This is simple thing. If we get something like that, we do the question like that. Then we can very easily summarize this lesson. Okay, right. Then I can try this one. For this one, now we write this. Integration x minus x upon x squared plus 1 dx. Right. Now I am going to integrate this separately and this separately. Then it is x power 1 more here. Then it is integral x squared by 2 minus. This one I have to integrate. I write it like this for a while. Then what I do is, here, when you differentiate this denominator, we get 2x. X squared derivative is 2x, no? 2x plus 0. Then I multiply here 2. To cancel down this 2, I divide this by 2 like this. By doing so, you can see, people, when you differentiate this x squared plus 1, when you differentiate this x squared plus 1, what we get is 2x plus 0. This 2x coming. Then the derivative of the denominator available at the numerator. Can remember today we learned something like this? Integration. Here we have fx, here f dash x dx. Then what is the answer here? L in modulus fx, no? Then that one we can apply here to get this answer, right? Then we get that answer like this. I write that here, x squared by 2 minus half L in modulus x square plus 1 plus C. C is any constant. Like that, we get the answer. Okay, next one. X minus 3 divided by root x plus 2 integral dx. This one now. How to take this? Here also, people, you can't see straight away a method among that 29 forms. We should be able to convert this to a form which is available among that 29 forms. That's only you have to do. Then the rest part we can do. Just try, people, this. How take this one? This one also we can write like this, people, x minus 3 root x plus 2, no? Right. Then I can write this one this way. Correct, no? 2 minus 5 is minus 3. This is coming. Okay. Now I divide this by this by this. X plus 2 divided by root x plus 2 minus 5 divided by root x plus 2. So now here the power 1, no? Then we get x plus 2 root at the numerator. This you can take to numerator. X plus 2 to the power minus half. Then for this one, I can write this. Then to integrate this one, integrate this. That way we can integrate this. Okay, right. Right. So then we can write x minus 3 divided by root x plus 2 dx. This is now root x plus 2 minus 5 times x plus 2 to the power minus half. Right, like this. Then this can be, people, integrated. Today we learned something like this: a linear function in x, ax plus b to the power n dx. So this answer, you know, people, what? Add in 1 to the power and divide by the new power, and meantime divide by the x coefficient a. You can apply that way here. Here x plus 2, root means power half, no, people? Then x plus 2, power half plus 1 means power 3 by 2. Divide by 3 by 2. Meantime, x coefficient is 1. We have to divide by 1. It won't change. Here, when you add 1, people, we get plus 1. Minus 1 plus 1 means plus half. Divide by plus half. X coefficient 1, we wrote this, C. C is any constant. Like that, we have to convert this to non-form like this. Right. That way you can work out that part. Right now. You see, we can take this answer, right? Okay, people, now we'll come to the next one. This sec x within bracket sec x plus tan x dx. See here, how to take this answer. Yeah, this one you can very easily take. Remove the bracket. Sec x into sec x. Sec squared x plus sec x tan x. You see. Dx. People, this sec squared x integral we know. But sec squared x, it is tan x, no? This is tan x. And sec x tan x, number 12 result you have, sec x tan x is sec x plus c. C is any constant. Like that, we get this answer, right? Right, next one, people. Next question is this. Integral of 4 minus 5 sin x divided by cos squared x dx. How to take this? Right. We can divide this by this. Then we can write 4 1 upon cos squared x is sec squared x minus 5 sin x divided by cos x is tan x. Another cos x we have 1 upon cos x sec x tan x. Now we can integrate this 4. This is tan x. 5 sec x tan x, people, we get derivative integral of sec x tan x, you know, it's sec x plus c. C is any constant, right? Right, people. We'll take another one question. Actually, I didn't prepare the tutorial including this kind of questions because I thought of doing this one. Right? This lesson I thought of doing without doing this part 10 straight away to come to the questions like in the examination. So therefore, I didn't prepare this kind of tutorial. Right. Anyway, people, only a few questions we have to write. Write down this one. Next one. Next question is this. The question is, people, if g dash x equals sec squared x plus cosec squared x minus 1. Sec squared x plus cosec squared x minus 1. And g 5/4 equals 1. Find gx. Find gx. This is the question. Find gx. Right. Here now, how to take this? We need to find this gx. G dash x means, you know, this notation dash stands for first derivative of gx function. Right. You know, if we differentiate fx function with respect to x, the derivative is denoted by f dash x, no? Right. Then people, starting from this f dash x to get this fx, we have to integrate f dash x. Integrate f dash x like this. Then we get fx plus c. Like that, people, here, in order to take this gx, g dash x is this. When you integrate both sides with respect to x, from the left hand side we get gx. The reason, when we differentiate f dash x, sorry, when we integrate f dash x, we get fx as the answer. So therefore, I take this g dash x is equal to sec squared x plus cosec squared x minus 1. Now I integrate in both sides with respect to x. People, left hand side, when you integrate, we get this. The right hand side, we have to integrate this way. Sec squared x plus cosec squared x minus 1 dx. People, you know, after integrating, we have to add the constant. No? Then we can add, after integrating this, we get gx. Correct? No? F dash x, when we integrate, we get fx plus c. And then like that, here we have to write gx plus c. Integrating this also, to the right hand side, we have to add another constant. People, if we take the left hand side constant to right hand side constant, the algebraic sum of two real numbers, no, constant means they will give another one real number. So therefore, in this case, no need to add, after integrating to both sides, two constants. Right? To one side, we'll add the constant. That's enough. Understand? Why? Left hand side, write in two constants. Once you bring one constant to other side, they together give what? Single real number. So therefore, I take like this. G dash x, when we integrate, we get gx. Sec squared x, when we integrate, we get what, people? Tan x. When you integrate cosec squared x, today we learned cosec squared x number 11 result, people. Cosec squared x integral is minus cot x. Remember, now you have to use them. Those results you should be able to remember. 1, it's x. And we'll write c. See, people, here this c, this c, in this case, not an arbitrary constant. You will find we can find this C. You will realize after finding this C people, this C will have a specific value. Then here we have to be very careful not to write arbitrary constant. C is a constant. Because we are given G pi by 4 as 1. To give for this G pi by 4 as 1 people, this C must have a specific value. Not for all values of C. If C is an arbitrary constant, this condition cannot be satisfied. So therefore, in this case, don't choose the word arbitrary. C is constant. Not any constant, no arbitrary. C is a constant, specific constant, right? Right? Special value this C has. Right? C is a constant. Just write down like that. C is a constant. C is a constant. Right. But people, now we can put for x pi by 4, because we have to evaluate this C, then only we know this dx completely. Right. So therefore, put in x equals pi by 4. We can write g pi by 4 is equal to tan pi by 4 minus cot pi by 4 minus x is pi by 4 now. Let's see. G pi by 4 given as 1, tan pi by 4 1, cot pi by 4 1, minus pi by 4 plus c. These two you can cancel down. Then we get c as what? 1 plus pi by 4. See here. This constant should definitely take this value. Otherwise, this g pi by 4 never be equal to 1. Okay. So therefore, this c is not any constant. It is a specific constant. It takes this value. So therefore, now you can put that CVR here, and then you can write Gx, right? Therefore, Gx is tan x minus cot x minus x plus c. This pi by 4 plus 1. This is how we take the task. Right. Right now, people, right? Okay, now come to this next. The next one is integral of e to the power 5 ln x minus e to the power 4 ln x divided by e to the power 3 ln x minus e to the power 2 ln x dx. Here 3 we have. See how to take this answer. Yeah, who got this answer? Who got this answer? Yeah, people now, this one you can very easily solve this way. In logarithm, we learned one result, one formula. It is people this. If we have a to the power log, this logarithm is as the power of a. Base of this log is b and here x. People can remember at the very beginning of your class only I did this logarithm. I wrote and proved this way one result. What is the result? The right answer can someone tell me? We said what? We can bring this way here and this way here. We can exchange these values. X log BA like this. One result we wrote like that. Second result is people this can remember this. A to the power log AX this way. This answer, people by using this result, this X and A places we can again exchange. X log base A. We brought this way here, this way here. But log A is, this is 1, no people? This is 1. Therefore, this is 6. Then you can literally see A to the power log AX. Here this log X to the base A is the power of this A. See in this case, this base of log being equal. That occasion, this is the answer. Understand? This is the answer. That one, when you use people, you get this answer very easily. You know, here, I can write this 5 as the power of this 6. That also, you know, we learned one result like this. R or else like this, no? Log base AMR. You can bring this before. R log AM. And then this coefficient of this log you can bring where here. Using that, you can bring this 5 as the power of X. You can write this one E ln X here. This 5 coming here means X power 5. Minus. Taking this 5 we are here. And similarly, this 4 we are here, we can take E ln X power 4. And here E ln X power 3 minus E ln X power 2. People, you know, ln X means what? Ln X means log base EX. Then we can see here, this is nothing but log base E x to the power 5. That means this and this bases being equal. If I write another one step, no need to that one, but you can understand if I write that one here. E, this ln means log E x to the power 5 minus E log E x to the power 4. Here E log E x to the power 3. E log E x squared dx. Here this base and this base being equal. Look at this. This and this being equal. Then you can apply this result. What? In this 2 are equal, this is the answer X. Then what is the answer of this? X to the power 5 minus X to the power 4 divided by X to the power 3 minus X squared. This is what we get. Now what do you get, people? We will take x squared out from the numerator. What is this? X cubed minus x squared divided by x cubed minus x squared dx. These two you can cancel out. Then we get only x squared. X squared integral is x cubed by 3. Plus c. C is any constant. C any constant. Right? This is how people we take that answer. Then definitely, if you know this one only, you can give a nice approach like this. Otherwise, you won't get an idea to work out this question. Right? Right, people. Okay, we'll take another one question, and when after finishing that, we can go to the trigonometric part. Then we can come to other questions, right? The next one is, people, this integration dx upon root x plus 1. This take this result. How to take this answer? Right, people, now here I multiply both this numerator and denominator by the conjugate of this denominator. Conjugate of the denominator going to be root x plus 1 and root x minus root x plus 1. And here root x minus root x plus 1 dx. And now this is a plus b into a minus b. Then that one you can write as a squared minus b squared. Then this square, when you square this one, root will eliminate, minus root will eliminate here. And here we have this root x minus root x plus 1 dx. Here you can cancel down this and this, we get minus 1. That minus sign we can write like this. Root x equal x to power half minus x plus 1 power half. This only now we have to integrate. Right? The integration of this you can do adding 1 here and dividing by the same new power. It is minus x power 3 by 2 divided by 3 by 2 minus x plus 1 3 by 2 divided by 3 by 2. plus c. C is any constant, right? Yeah, that you can take. Right. People, now we'll come to some trigonometric integrals. Sine cube x into cos cube x dx. Sine cube x into cos cube x dx. Yeah, how to take this answer, people? Right, this one you can write this way. We can multiply this by 8 and divide by 8. These two will cancel off, the same thing coming. Sine cube x cos cube x dx. This is 1 upon 8. This one you can write to sine x cos x to the power 3. 2 to the power 3 is 8 coming dx. 1 upon 8. 2 sine x cos x means, people, sine 2x. That to the power 3 means sine cube 2x dx. Something like this you get. Right, now how to people integrate this? To integrate that, you can use this formula. We know sine 3 theta formula. 3 is sine theta minus cosine cube theta. This formula you can use. This is trigonometric formula. You can subject this sine cube theta by that. Sine cube theta once you subject, we get 3 sine theta minus sine 3 theta divided by 4. Like this. Then, people, when you put for this theta 2x, we get this. Therefore, sine cube 2x. You can write substitute for theta 2x. We get 3 sine 2x minus sine here 6x. No, this one we get. Then I can replace this by this. Then you can integrate that. 1 upon 8 sine cube 2x we can write. Another 1 upon 4 come in. Therefore, here 32. No. Now 3 sine 2x minus sine 6x dx. Now integrate this. 1 upon 32 within bracket 3 times. People, what is the sine 2x integral? Sine x integral is minus cos x. Then sine 2x minus cos 2x divided by 2. See that x coefficient by x coefficient we have to divide. Then it is minus cos 2x by 2. Here also minus with this minus sign plus cos 6x by 6 plus c. C is any constant, right? People, before going to the next part, we come to the break and we'll continue the lesson from there. Right. We come to the break then now. Come at 10. Right. Next question, people, this dx upon sine squared x cos squared x. Right. Right. I'll write some questions. Number 2. Cos 2x plus 2 sine squared x dx divided by cos squared x. Number 3. Sin x plus cos x divided by square root of 1 plus sine 2x dx. Number next. Integration of 1 minus cos 2x divided by 1 plus cos 2x. Right? Right. Yeah, people. These questions first. Right. We'll take one by one. Right. Take the time and first work out the questions. I'll give 2 minutes. One upon sine squared x cos squared x dx. You can write this one. This equal. I multiply this by 2 and divide by not 2, 4. 4 sine squared x times cos squared x dx. Now you can write this one as this one. You can write 2 squared sine squared x cos squared x 2 sine x cos x perfect squared. That is sine 2x perfect squared means sine squared 2x like this. Correct, no? 4 sine squared x cos squared x you can write as 2 sine x cos x perfect squared. 2 sine x cos x is sine 2x perfect squared means sine squared 2x. 1 upon sine squared means cos x squared 2x dx coming. But people, you know cos x squared x integral. Cos x squared x integral is minus cot x. Then here 4, this is minus cot 2x divided by 2 plus this, and this you can cancel down, minus 2 cot 2x plus c. C is any constant. The reason is, people, you know, we learned today cos x squared x integral is minus cot x. Okay, then here we have cos x squared 2x. X has a coefficient. By that coefficient, we have to divide. Right? If we have 2x here, 2x come in here, and by 2 we have to divide. That's the reason. Right. This is okay. Count second one. Count second one, people. right? It is cos 2x plus 2 sin squared x divided by cos squared x dx. Here this is written cos 2x I can write as this say people cos 2x we can write 1 minus 2 sin squared x plus 2 sin squared x. We know for cos 2a there are 3 formulas now people. Cos squared a minus sin squared a, 2 cos squared a minus 1 and 1 minus 2 sin squared a. Then I wrote that like that. Then here we have cos squared x dx. These two you can cancel down. And here we have 6 squared x dx. 6 squared means people tan x plus c. C is any constant. And next one, this third one. Sin x plus cos 6 divided by square root of 1 plus sin 2x dx. How to take this answer? This one within the root sign people I can write as cos squared x plus sin squared x. And this sin 2x I can write as 2 sin x cos 6. To sin x cos 6. Dx. If within this bracket, sorry, within this root sign, it is really the perfect square of cos 6 plus sin x, no? This one. This is sin x plus cos 6 perfect squared root dx. Then the square will eliminate when you take the root. Then sin x plus cos 6 will cancel with this. This 2 will cancel. We get 1 dx. It is 6 plus c. C is any constant. C is any constant. Right. This is okay. Now this. Number next, this one people. 1 minus cos 2x divided by 1 plus cos 2x dx. Right now, write down this cos 2x to cancel down this 1 as 1 minus 2 sin squared dx. This 2 cos 2x we write as 2 cos squared x minus 1, right? like this. These two can cancel down. This and this you can cancel down. Minus minus plus 2, we can cancel down with this. And here we get integral sin square divided by cos square dx. We get tan square dx. Tan square dx, right? At tan square dx, you can write people 1 plus tan square dx is equal to 6 square dx. Then tan square dx can be subjected taken this right hand side. Then tan square dx we can write 6 square dx minus 1 dx. 6 square dx integral is tan x. Minus 1 is x plus 3. See if any constant. Like that, you can take the last answer, right? Right. Right, we will now we'll come to the another few questions and go to the next part. Right. The next one is people this sin square dx divided by 1 plus cos 6 perfect square dx is the next one. Yeah, what this sounds. Okay, this one I can write people this way. Sin square dx divided by 1 plus cos square dx perfect square. No, I can write that within the bracket, having perfect square here. Right. And now this cos 6 I'm going to write people 1 minus 2 sin square x by 2 like this using half angles. For cos A you can write 3 formula, no? Cos square a by 2 minus sin square a by 2. 2 cos square a by 2 minus 1. 1 minus 2 sin square a by 2. No, the other way around we have write. To cancel down this one we have write. And I'm going to write 2. Yeah, that way. 2 cos square a by 2 minus 1 will write like that. I'm going to write this cos 6 like this. 1 cos 6 we write 2 cos squared x by 2 minus 1. This I write. These 2 now you can cancel down. Sin x I can write as 2 sin x by 2 into cos x by 2 divided by 2 cos squared x by 2. This way I can write this. It's 2 and this 2 you can cancel down. 1 cos x by 2 you can cancel down with this. Sin x by 2 divided by people cos x by 2 means tan x by 2. But here we have a square, then tan squared x by 2 comes dx. Tan squared x by 2. Right. Now this one again you can try tan squared x by 2 you can write by using that formula sec squared x by 2 minus 1. This one. Sec squared x by 2 minus 1 dx. Now this one people, what is integral of sec squared x is what? Integral of sec squared x tan x, no? But here we have x by 2. Then tan x by 2 divided by x coefficient. What is x coefficient people here? X coefficient is half. Then this answer is what? Tan x by 2 divided by half minus x plus c is any constant, right? Right. And now people will come to another few questions like this. Cos 4x into sin 2x dx. Sin cos product there we have. Sin cos product there we have. Yeah, in this case, to take the answer, people, we can use that product formula. Right, you know, we learned in trigonometry 4 product formulae. Can remember that 4 product formula, people? We had 2 sin A cos B, 2 cos A sin B, 2 cos A cos B, 2 sin A sin B. Can remember this formula, people? 2 sin A cos B, what is the formula? Sin A plus B plus sin A minus B. This one, when the cos comes beginning, sin A plus B minus sin A minus B. This one, cos A plus B plus cos A minus B. What is this? Cos A minus B minus cos A plus B. Right. Then when you have this way product of sin and cos, we take the answer like this. How we write that one as a difference of sum. Thereby you can integrate one by one. Right. So then we get there. First one, integral of cos 4x into sin 2x dx. I multiply this by 2, divide by 2. like this. 2 cos 4x sin 2x dx. And now this is like 2 cos A sin B form here. You can write it like this. In this right hand side, you can write half. It is sin A plus B. A is this, B is this. Then 6 come in. Minus sin A minus B. 4x minus 2x is 2x. Right? Then you can integrate this. Here this is minus cos 6 by 6. Here we get plus because that minus and this minus cos 2x by 2 plus C is any constant. And now we'll see we get sin cos 3 terms in the as the product like this. Next example come. Sin 2x sin 6x cos 8x dx. This kind of thing. Suppose how to take this. Yeah, what we do is this. We divide by 2, multiply by 2. Like this. We write this within bracket. And this cos 8x dx. For this, we apply this formula, 2 sin A sin B, and write it like this. Right? Now multiply that by cos 8x, the difference. And for that difference, again, product, no? Apply again these 2 formulas. And then you can integrate that. Then here we get half 2 sin A sin B is cos A minus B. A is this, B is this. 2x minus 6x is minus 4x. Cos minus 4x. You know, people, when we write cos, we can ignore that minus sign. Cos 4x. Cos minus theta is cos 6. Cos theta, no. A minus B minus cos A plus B. Cos 8x. Cos 8x dx. Now multiply this and this and this and this. Then we get this one. I can write half integration cos 4x cos 8x minus cos 8x cos 8x cos squared 8x. Right? Dx. Now we multiply this by 2. and divide by 2. Right? We divide by 2 and multiply by 2. This one only, yeah. 2 cos 4x cos 8x. And this cos squared 8x, we write people, we know we have cos 2a formula. One formula we have 2 cos squared a minus 1. Then when you substitute cos squared a here, taking this side, 1 plus cos 2a divided by 2, like this. Then the relation between the angles left and right is, we multiply the left hand side angle a by 2, we get the right hand side angle. Then using that, we can write this cos squared 8x like this, no? Cos squared 8x. For this a put 8x, then here will be 16x, no? 1 plus cos 16x divided by 2 is this. And this. Now people, we can write, here we have half, no? Open bracket, 2 cos a cos b. 2 cos a cos b. This one, cos a plus b plus cos a minus b. Cos a plus b, then 12x plus cos a minus b, no? 4x minus 8x minus 4x, but since we write cos, no? Cos 4x. Right, no? Cos 4x minus 8x. Cos minus 4x. Cos minus theta is cos theta. Therefore, we can ignore this minus sign. Here, we can write, take this half, 2 out, then half. 1 plus cos 16x. Dx. Right. Now integrate 1 by 1. Here is half. Here half. Here sine 12x by 12. Sine 4x by 4. Half x sine 16x by 16. Plus c. C is any constant. Right. So then this way, people, if you get sine cos product, something to integrate, this way you can take them, right? But this part we learned in our theory as under one separate topic. Okay, so but I'm not going to discuss like that. Right, this way enough. Right. Next one is this. This one, sin x divided by 1 plus sin x. How to take this answer? Yeah, so here to take this answer, sin x, we multiply both the numerator and denominator by the conjugate of the denominator like this. Dx like this. Yeah, here this and this you can multiply. Sin x minus sin squared x. People, here what do you get? 1 squared minus sin squared x. 1 minus sin squared x, no? Then this is sin x minus sin squared x divided by, this is cos squared x dx. Okay. Divide this by this and this by this. Sin x by cos squared x. One cos x and the sin x when you take, sin x by cos x is tan x. Other cos x is 1 upon cos x. Then we get sec x tan x, no? For this division. This and this when you divide, we get minus tan squared x dx like this. People, this tan squared x you can write as sec squared x minus 1. You see. Now, sec x tan x integral is what, people? Sec x. Sec squared x integral is tan x. This one is x. Then you get the answer. Sec x tan x is sec x. This one minus tan x. Minus minus plus 1, no? Plus 1 integral is x. Plus c. C is any constant. C is any constant. Next question, people, this 1 upon 1 plus sin x dx. 1 upon 1 plus sin x dx, right? Take this, people. Here also we multiply both numerator and denominator by the conjugate of the denominator. Like this. One minus sin x divided by 1 plus sin x into 1 minus sin x dx. Yeah, here a plus b, a minus b. 1 squared minus sin squared x. 1 minus sin squared x, no? Dx. 1 minus sin squared x, people, cos squared x. Then this is now 1 minus sin squared x sin x divided by cos squared x dx. This and this we can divide. Sec squared x minus, right, sec x tan x. Coming like this. Sec squared x mean, people, integral of sec squared x is tan x. Sec x tan x means sec x plus c. C is any constant. Like that we can take that answer. People, next one is this. 1 upon 1 plus cos 6 dx. This one, take. Take this answer, people. Right now here, this one you can write, people, like this. 1 upon 1 plus this cos x we write 2 cos squared x by 2 minus 1 this way. And this you can cancel out. This 2 you can take out. Then we have this 1 upon cos squared is, people, sec squared x by 2 dx. You can write sec squared x by 2 integral. What, people? Tan x by 2 divided by what, people? Half, no? Yeah. Half tan x by 2 divided by half plus c. This 2 you can cancel down. C is any constant. C is any constant. Right, next one. Right, integral 1 upon 1 minus cos 2x dx. Take this. Yeah, here this one I can write. The conjugate method is okay. But see this method, 1 minus cos 2x we write as 1 minus 2 sin squared dx. Dx. Cos 2x we can write as 1 minus 2 sin squared dx. This and this you can cancel down, minus minus plus, take this 2 out, half 1 upon sin squared dx. This is now cos x squared dx, no? You know integral of cos x squared dx, people, minus cot x. Minus half cot x plus c. C is any constant. C is any constant. Right. But now we'll come to another subheading, people. Write down subheading like this. Integration used in substitutions. Integration used in substitutions. Subheading, write down. Integration used in substitutions. Right, we'll come to one question there. Subheading is integration using substitutions. Right, we'll take some question under this. First one is x upon square root of 2x squared plus 3 dx. Right. Right. Here, people, we can take the answer. I'm going to use substitution like this. And secondly, second method I am going to tell you. Right, let we use a substitution. For this part, we use a substitution as t. Like this. Whenever we use a substitution, people, first thing is we have to differentiate this substitution. Right? Using this t, 2x squared plus 3, we are going to work out the question finally in terms of t. Right. So therefore, this dx and this every x we have to replace by t. For this, we have differentiate this with respect to x. 4x coming, no? dt upon dx, 4x. Then by this subject, people, this what? Dx, dt upon 4x is this dx. Now we use this. It is this. This is a question. Right. Now, here we have x. 2x squared plus 3 is t. Then within the root sign we have t. And this dx, dt upon 4x. This and this you can cancel down. Take this 4 out. 1 upon 4, 1 over root t dt. Right? This root t, people, you can take to numerator. Root means power half, no? Then t to the power minus half coming like this. Dt. Then we can integrate this with respect to t. How? Add 1 to this power and divide by the new power. Then once we add 1, we get plus half. Right? Divide by half. Right. Now this 2 and this 4 we can cancel down. Here we get half, no? Then 2, no? When you add this 1 here, power half coming. Then here we get the answer. 2 and this 4 when you cancel down, half root t. Now we have to write for this t. Final answer you have to keep in terms of x, because the original answer, original question given in terms of x. T is this 2x squared plus 3. Plus c. C is any constant. Right. People, now the same answer we can obtain very easily in other way. What is that? In the morning we discussed one relation like this. We have f dash x times fx to the power n dx, like this. Okay. Then this answer is fx to the power n plus 1 divided by n plus 1. Can you remember that? Right. N not equal to minus 1. Using that, you can very easily take this answer in another way. Under second method, right? Integral x upon square root of 2x squared plus 3 dx. You can bring this to numerator. What is that? 2x squared plus 3 to the power minus half dx. Now it is equal to this thing. Here the function fx, I am going to consider this function as this. N is minus half. Then of the function fx, we should have a derivative before. The derivative of this part is 4x. So then I multiply this by 4 divided by 4. Divide by 4 like this, multiply by 4 like this. That one now. 2x squared plus 3 to the power minus half dx. The second method, this one. Then we can apply this result. Fx to the power n, here fx is this, n is minus half. The derivative of this available here. Okay, fx root is f dash x. Then the answer is that. Adding 1 to this and dividing by the new value. Then we get 1 upon 4, 2x squared plus 3 to the power. Add 1 here, half, divided by half. Cancelling this and this, we get 2 half 2x squared plus 3 to the power half coming with the constant here. Same answer comes. That is another way of getting the same answer. Right. Next one, we tell this. Next question. Right. The question is this: sine 2x divided by a cos square dx plus b sin square dx, right? Right. Take the substitution. T equals a cos square dx plus b sin square dx, where this a and b are constants. Right. Take this. Right. First, differentiate this function. Substitution. People, by doing this way, the questions only we can practice, right? So therefore, by every question you get something. So therefore, only way of improving the skill of working out this lesson is people doing more sums, right? Then here, differentiate this with respect to x. A is a constant, 2 cos x derivative is minus sin x. Here, b times 2 sin x derivative is cos x. Then here we get 2 sin x cos x sin 2x, 2 sin x cos x sin 2x. Then we get b minus a sin 2x, no? dt by dx. Then we can subject dx by this dt upon b minus a sin 2x. Put that pair here. A cos square x plus b sin square x equal t. This is t. Dx is dt upon b minus a sin 2x. These two you can cancel down. Take this b minus a out. 1 upon b minus a. 1 upon t dt. Right, people, what is 1 upon t? Integral of 1 upon t. Integral of 1 upon x is L in x. This is L in t. Not t, right? Substitute for t this. T is a cos squared x plus b sin square dx plus c. C is any constant. Like that, we can take this by using this substitution. Right now. Yeah, the next one is cos root x upon root x dx. Take a substitution like this, t equals root x. T equals root x. Right? Then we have to differentiate this dt upon dx coming as 1 over 2 root x. No? By this, we can subject dx to root x dt. We come to this. Cos root x divided by root x dx. Root x is t. Therefore, this is cos t divided by root x is t. And dx, I keep here root x. And dx is 2 root x dt. This and this you can cancel down. Take this 2 out. Cos t dt. Integral of cos t is, people, sin t. Yeah? Therefore, we get the answer 2 times sin t plus c, but t is root x. No? C is any constant. Like that, we get this answer. Right. Next question is integration of ex times 1 plus x divided by cos squared x ex dx. Cos squared x ex. People use a substitution, t equals x ex. Right? Now at the examination, sometimes there can be a question by using suitable substitution. Then by doing this way, some questions only, people, we get the practice of determining the suitable substitution. Otherwise, nobody can say straight away in common what is the substitution for this kind of questions. No. By doing like this 10-15 questions, people, automatically you can determine the suitable substitution for the given question to use. Okay, so that is why we must do some sums under this. Right, now take t equals x ex and see what happens here. Differentiate this t dt over dx. This we have differentiate as a product u into v form. Keep x as the same, the root of ex is ex. Ex as the same, root of x is 1. Then we get dt upon dx. Take ex out, 1 plus x. Then dx going to be dt upon e power x divided by 1 plus x. This here. Put that here. Right? Ex times 1 plus x divided by cos squared x ex people t, and it's dx dt upon what? E to the power x times x plus 1. Completely this part you can cancel down with this. This is sec squared t dt. This is tan t. Integral of sec squared t tan t. T is x ex. Tan x ex plus c. C is any constant. That's how we take that answer. Right. Next question, people. X squared ex cube cos ex cube integral dx. Ex cube cos Ex cube dx. Here substitution t equals Ex cube. Take the sweep. Right, what's the answer? First differentiate this. Ex cube, when you differentiate, we get this and multiplied by the root of x cube. It is 3x squared. Then this you can write x squared dx cube cos Ex cube is t, and dx going to be dt upon Ex cube 3x squared. Then x squared and Ex cube we can cancel down. This 3 can be taken before this. 1/3 cos t dt. This is sin t. T is that sin Ex cube plus c. C is any constant. This is how we take that answer. But for the next one. One over x cube sine pi upon x squared dx. Put a substitution pi upon x squared as t. Right. Take that. Here is this answer. Dt upon dx. This pi is a constant. Take this x squared to numerator. X to the power minus 2 coming. Then we get minus 2 comes before x. Minus 2 minus 1 is minus 3. Dt upon dx minus 2 pi divided by x cube. Now come to the question now, put that there. Then we get here 1 upon x cube sine pi by x squared. Dx is therefore 1 upon x cube sine pi by x squared is t. Dx you can subject people. It is x cube upon minus 2 pi dt. This and this you can cancel down. Minus 2 pi comes before this. It's a constant. Something like this we get. Sin t integral is minus cos t. That minus and this minus make plus. Cos t. T is this answer. Cos pi by x squared plus c is any constant. That way we take that answer, right? The next question is this. X to the power half 1 plus x to the power 3 by 2 whole thing to the power 1 by 4 dx. Is the question. X to the power half, then bracket 1 plus x to the power 3 by 2 outside of that 1 upon 4. Take people here substitution like this. T equals 1 plus x to the power 3 by 2. This way. Take this. And take this answer. Take this. When we differentiate this, we get dt by dx. This is 0, 3 by 2, x half. 3 by 2 minus 1 is half, no? And then dx can be subjected 2 by 3 x to the power half dt. 2 by 3 x to the power half dt. Take that here. Three by 2 to the power 1 by 4 dx is equal to x to the power half 1 plus x power 3 by 2 is t, and that to the power 1 by 4 and dx 2 by 3 dt. This 2 we can cancel now. Take this 2 by 3 out. Right. How to integrate this? Add 1 here and divide by the new power. So what do you get? 2 by 3 t to the power 5 by 4. Now once we add 1, divide by 5 by 4 plus c. Then we get 8 by 15. T is that 1 plus x power 3 by 2 to the power 5 by 4 plus c. C is any constant. This is how we take that. Right, next one, people. Next one is this. This x plus 5 divided by root minus x squared dx. Right, people, this time I'm not going to give you the substitution. Right, you can work out this by using a substitution. Without using substitution also you can work out. First, use a substitution. Determine the substitution yourself and take the answer. And secondly, without using substitution, we know how to get this same answer. Right, we'll do in both ways. I take this answer. The first method is this. You can write this divided into two parts like this. X divided by root of 1 minus x squared dx, and 5 divided by this. No, that 5 can be taken out. This way you can write it. This is nothing but sine inverse x. No, this one can be done like this. I bring to numerator 1 minus x squared to the power minus half dx plus 5. This is sine inverse x. Then you can think here, people, this is your fx function. We have a theory like this, no? F dash x times fx to the power n. This one we know fx to the power n plus 1 divided by n plus 1. Yeah. Then here fx function, if we consider like this, its derivative we should have here. The derivative is minus 2x. Then what I do is I multiply this by minus 2 and divide by minus 2 like this. Dx right like this plus 5 sine inverse 6. Right. Now fx is here, its derivative is here. Now you can take the answer like this. Minus half. This add 1 and divide by 1. Once we add 1, we get half, no? Divide by half. Plus 5 sine inverse 6. This you can cancel now. Plus c. C is any constant. That you can take that answer. Right. This is the first method. If you use people's second method, right? We'll take a second method like this. Now I'm going to write second method. Second method. I know first method, okay. Second method also, we need this step. Right. I take this as I. What? This part. This is equation number 1. Now I'm going to evaluate this I using a substitution separately. Under second method, right? I is equal to x upon this. I'm going to use this one as our substitution. T equals 1 minus x squared. Right. Though you use 1 minus x square root as t, also correct. Then we get dt upon dx. Is people minus 2x, no? Then dx is equal to dt divided by minus 2x. We get, right? Bring this side. No? Then we can start by this. I equals x upon root t. 1 minus x squared t, no? And here dx, no? We had dx. Dx is minus dt upon 2x. This and this you can cancel down. This 2 you can write as half like this. Take this minus sign also out. 1 over root t dt. Take this numerator. Then we get what, people? T to the power minus half dt. Add 1, then plus half divided by half. Then what do you get? I equals minus half t to the power plus half divided by half. These two you can cancel down. I equals minus t to the power half. T is, people, this answer. Put that there, you get the same answer. In that way, people, you can determine the suitable substitution. Right, we come another one more. X cube divided by square root 1 minus x power 8 dx. X cube divided by square root of 1 minus x to the power 8 dx. Right, take this paper as the next one. Determine a suitable substitution. Use a substitution t equals x to the power 4. Differentiate that. Dt upon dx is 4x cube. Dx is dt upon 4x cube. Right? Then come to this. One minus x8 means x42 no t square dx dt by 4x cube. These two can cancel now. Take this 4, this as 1 by 4. 1 over root dt. So what is the integral of this? This is sine inverse t, no? Sine inverse t. Sine inverse t. What is t? X power 4. Sine inverse x power 4 plus c. C is any constant. Next one. E to the power 2x divided by square root of 1 minus e to the power 4x dx. Take this. Now you can decide what should be the substitution there. E to the power 2x divided by square root of 1 minus e to the power 4x. Got the answers. Right. What is the substitution here? T equals e to the power 2x. Then we can write dt upon dx e to the power 2x into 2. Dx is equal to dt upon 2 times e to the power 2x is t. Or 2 e to the power 2x, we can keep like this. Now take this. E to the power 4x means people e to the power 2x power 2, no? And that is t squared, no? Dx dt upon 2 e 2x. This 2 can cancel down, this 2 comes here half. This way, people, now we can determine the suitable substitutions, right? Sin inverse t, t is e to the power 2x plus c, c is any constant. Like that we get. Right. We'll take another one question. And then in the next class, we're supposed to discuss integration by parts and t equals tan x by 2 substitution, right? And then we come to the definite integration part. And another tutorial I have set, I put that also to do the questions, right? And the one more people. It is this. Cos x minus sin x divided by 1 plus sin 2x dx. Here we use a substitution t equals sin x plus cos x. See how to get this answer by using this substitution. Now we can differentiate this with respect to x. Sin x derivative is cos x derivative is minus sin x. Then dx is dt upon this. Right, now this one we can write cos x minus sin x by 1 plus sin 2x dx. This one I can write cos x minus sin x divided by, this is sin x plus cos x perfect square, no? Like this we can write now. But A reason here, when you simplify this, what you get? Sin squared x plus cos squared x. They together 1. Middle term is 2 times sin x cos x. Sin 2x. This is coming. Right. Then cos x minus sin x divided by, this is people t square. Dx is dt upon cos x minus sin x. These two you can cancel out. 1 upon t square dt. Take this numerator, t to the power minus 3 dt. Add 1 to the numerator power and divide by the new power. Minus 2, no? When you add 1, t to the power minus 2 divided by minus 2. Then this is minus half 1 upon t squared. T squared is this sin x plus cos x perfect squared plus c. C is a constant. Sorry, here it's wrong. When you take this numerator minus 2, no, minus 2 plus 1 is minus 1. Minus 1 divided by minus 1. Right. I made a mistake. It's a huge mistake. Minus 1. This. Right now. Here, people, we get minus 2. Add in 1. We get minus 2 plus 1 is minus 1 divided by minus 1. Right. And then, people, I supposed to come to the end of the today lesson here. And evening like 1:30, we start the paper number 14, the discussion. Okay. So then next day, we try to come to the end of this question discussions. Doing the rest possible parts of the lesson, right? So what are the rest part? Integration by parts and some other things. And then we come to the definite integration part. After that, we come to the question discussions of the second tutorial. Okay, fine. So then we meet people in the evening. Paper number 14 is to do, no? Right. Right, people, then we stop here the morning session, right? Okay.